The two new Laplace transforms that we picked up are valuable to learn to work with, especially number two. Number one is the Heaviside Laplace transform, and that, notice, simply is whatever our Heaviside time is, where it switches on, that is the value that goes in for A on the right-hand side. So we go from the T domain into the S domain, excuse me, and so in this case, we would have e to the negative 3s over s. Simple as that. That's what that looks like. Now, the second one could be a little intimidating to work with that first because there's a lot of notation. But here's the thing to remember. Here you have to have a Heaviside at t equals a. And then that needs to be multiplying a function that is shifted to the right a units. Now technically you could say to the left, but we don't deal with negative time very often, so it makes sense that this would always be a shift to the right. So this must be a shift a units to the right. And as long as you have that, a Heaviside at time a multiplying a right shifted function, then the way that you take the Laplace of that is, first of all, you identify, well, what is a, and is the, not the shifted function, but what is the root function? F of t, this is the unshifted version of that function. So let's take a look at an example. So notice that here we have an a value of 3, and that here in the exponent we can clearly see that this is our right shifted function 3 units to the right. So here we could also see that this is the t minus a. Okay, so in order to do that, so we have that a is equal to 3. We also have that f of t minus 3, the function shifted 3 units to the right, is e to the negative quantity t minus 3. So in order to convert this into this form, we needed to know what a is. So we know that for sure this is going to have e to the negative 3s in it. But now it needs to be multiplied by the Laplace of f of t. What we identified on the left-hand side, that was f of t minus 3. So if we replace t minus 3, or t with t minus 3 to get e to the negative quantity t minus 3, then the original unshifted function, f of t, is the same idea as shifting it, right? Now replace the t minus 3's with just t. So this should just be negative t. That would be the unshifted version of the function, right? E to the negative t minus 3, that's shifted to the right 3 units. E to the negative t, that is not shifted at all. That is exactly where it should be at the origin. So in other words, this guy, right, would be shifted 3 units to the right and then decays, but this is the unshifted. So basically what you have to do is you have to unshift the function. Replace the shifted portion with just t. All right, well that gives us that this is going to be e to the negative 3s times the Laplace of e to the negative t. Well, we already know that the Laplace of e to the at is equal to 1 over s minus a, and so this will simply become e to the negative times 1 over s. Now a in this case is negative 1, so this will be s plus 1, right? Because the signs are opposite of one another. And there we go. That is how we find the Laplace of a function that is shifted. Now that's the important part. The function has to be shifted a units to the right, and if it's not, then we've got to figure out a way to do that. All right, now let's see how we work backwards. So given that this is already the Laplace transform of some function, of what function is it the Laplace transform? Notice that in this case, e to the negative 3s came from our Heaviside. That came from the fact that a was equal to 3, giving us e to the negative 3s. So e to the negative 4s would have had to come from a Heaviside with a equals 4. Okay, now this function here is analogous to this function over here, right? This is already the Laplace of some f of t. So you have to begin by thinking about, well, what is the inverse Laplace transform of that? And if we recall that the Laplace of t to the a power for any integer a is, or I guess we wrote it as t to the n, is n factorial over s to the n plus 1. And the reason I'm saying that is because what we have, this 1 over s squared, would actually be the Laplace of t to the first, because then we would just get 1 factorial, which is 1, over s to the 1 plus 1, which is s squared. So that means that the f of t that produces a Laplace transform of 1 over s squared, the f of t that produces a Laplace transform of 1 over s squared is the function t to the first power. And now all we're doing is we're working backwards from where we were in part B. So here in letter C, we're starting with the rightmost portion and we're working our way back, right? So if our f of t is t transform, we would need to know what the f of t minus a is. This is the f of t minus a. So if f of t is t to the first, then that implies that f of, well, t minus 4, because a is 4 in this case, would simply be a matter of replacing the t with the t minus, right? The input gets replaced with t minus 4, so this would be t minus 4 to the first power. And that's all we need, my friends. All we need to know is what the a is, and then what the f of t minus a is, and then the inverse of that would be the Heaviside at time 4 times f of t minus 4. So to answer this original question, this will equal u sub 4 of t multiplied by f of t minus 4, which is t minus 4 to the first power. Of course, you don't need the first power there. I'm just trying to make it clear that what we're doing is we're replacing t with t minus 4. That if you take its Laplace transform, you will get e to the negative 4s times 1 over s squared. So the key parts, notice in letter B, when you're taking the Laplace of a Heaviside times a shifted function, you've got to think about that shifted function as the function shifted a units to the right. And then you need to figure out what was the f of t, the unshifted version of that function, and what's the value of a. With those two pieces of information, with what is a and what is f of t, then that allows you to form this statement. You have to take one Laplace transform and then you're done. When you're working backwards, you have to do the reverse, exactly the reverse of that. So we need to identify what a is still, and we need to observe that f of t, well, what is the f of t that produced 1 over s squared? And then once we have that, then we need to shift it 4 units to the right. Remember over here, we had to unshift it. So we have to shift it 4 units to the right, and Heaviside at time 4 times f of t minus a is exactly what the inverse of this guy is. We'll take a couple of applications now to see how cool this stuff can be when modeling.